Now we're continuing with part 2 of our fluid flow project. We are doing 2D flow simulation of airflow over a flat plate. So we want to start with our design modular. We're going to go ahead and create a sketch in the 2D plane. Just gonna make a rectangle. And then we're going to go ahead and dimension that rectangle. We want our height to be, or in meters, we want our height to be 0.1 meters. And we want our length to be 1 meter. I'm going to go ahead and apply that surface from sketch. And then go ahead and generate. And there you go. We have our surface that we're going to be producing our flow simulation over. So we can go ahead and exit this. And we can go ahead and come into our mesh. Now that we're in our mesh, we want to go ahead and produce a face mesh. So we just want to go ahead and do like this. And go ahead and generate. Now we want to go ahead and insert sizing. I'm going to go ahead and click the top edges. Apply. Instead of going by element size, we're going to do number of divisions. We're going to do 50. And we're going to go ahead and do hard behavior. And we want to create another sizing. And we want to do the left edge. Apply. Number of divisions. We want to do, in this case, we want to do 60. We're going to go ahead and specify hard behavior once again. And then in this case, we're actually going to have a bias type. And our bias factor is going to be 70. And then we're going to do basically repeat the same process. Insert a sizing for the right edge. Apply. Just want to go ahead and do number of divisions, and then it's going to be 60 for this one as well. And then we're going to want to do the hard bias. In this case, we want to have, hard behavior. In this case, we want to have bias once again, and have the bias factor of 70. And we want to go ahead and do reverse bias. apply, and there you go. So we can go ahead and generate all this. We also want to assign some names, so we're gonna just want to go over here to our face selection, select the face. I'm gonna name this airflow. Also gonna be assigning edges. This could be inlet. This is gonna be outlet. This is gonna be our plate. And then this right over here is gonna be our far field pressure. Sorry, far field pressure. So now that we're done with that, we just want to go ahead. Beautiful mesh we've got going on. We're going to go ahead and exit this out. Yes, save, make sure to save that. Oh. I'll just give that a second while it loads. That wasn't supposed to close. Let's open that back up. Apologies for the interruption. All right, we're back where we left off. I'm not sure what happened there, but we want to go ahead and update our mesh. Make sure that's updated. That'll take a minute. Now that that's updated, we want to open our setup. I'm gonna go ahead and have double precision. We know we have 20 cores, so it's gonna be 19 processes, and we want to go ahead and start that up. Now, all right, now that that's loaded, we just want to go ahead, check it real quick, make sure everything's good. We're done, so that's good. I'm gonna head over to models. Want to head over to models, make sure that our simulation is laminar, since we are working with a laminar hypothetical. And then we are going to be changing Oh, give this a minute. We are going to be changing a couple of the properties of our air. So instead of 1.225, we're going to do 1.2 for the density. And then instead of 1.7 to negative fifth times 10 to the negative fifth, we're going to do 1.8 times 10 to the negative fifth. So just create the update that real quick. And then we can close. We want to go ahead and head over to our boundary conditions. At our inlet, we want to change the velocity to 2 meters per second as specified in the instructions. Apply that and close. And then at our far field pressure, we just want to go ahead and change the type to symmetry and apply. Close, and we should be all good. Just double check, yeah, symmetry. So we should be all good. And then we want to head over to methods. At methods, we can do the simple scheme. Make sure that's changed to that. And then from there, we want to head over to monitors and change our residuals to 1 times 10 to the negative 7 for all three of them. For all three of our residuals, which is continuity, x velocity, y velocity. Now that that's changed, I'm going to go ahead and start our initialization. Ensure we're in hybrid, and then, ensure we're in standard. And then we want to go ahead and compute from our inlet. And we can go ahead and initialize. And we want to go ahead and run calculation. Make sure a number of iterations is high. I'm going to do 1 times 10 to the 6th. And we can go ahead and calculate. And our calculation is done. Oh, no, it's going to calculate now. Beautiful. So that's just going to go ahead and take a while. So I took the liberty of just doing this off screen, but our calculation has gone ahead and finished. So we can go ahead and close this window out. Now that that's done, we can go ahead and open our results. Now that we're here on the results section, we want to go ahead and create a pressure contour plot. Name this pressure. That's going to give us all domains. We want to make this location symmetry 2. Pressure, that's what we want. And then we'll do about 100 contours and then go ahead and apply that. Beautiful. Actually, we'll do 500 contours. Make it a little smoother. Much better. So then we'll go ahead and just do the same exact operation with our velocity vector contour plot. So velocity. It's going to be in symmetry 2. Then just make this the general velocity. And go ahead and do about 500 contours. Just take off lots of pressure. As you can see our boundary layer forming right there. It's beautiful, nice, beautiful boundary layer. And then it widens up as the boundary layer thickens all the way up to the end of the plate. And then the final step, which we wanted to do, was create a velocity vector as such. And just make sure that's once again symmetry 2. And let's go ahead and uncheck this so we can see it. And as you can see, it is a little crowded, but it's in essence the same thing as the velocity plot. We can probably make this a little bit better. Symbol size 0.5. What about 0.1? That's a little bit better. You can see it much more clearly. And then now that we're done with that, we just want to go ahead and make our chart. This is going to be our velocity. Actually, before we go ahead and do this, let's add 2 lines. X is equal to x35. And then this one's going to be, let's just go ahead and put this back to, actually, let's take all these off. Let's go ahead and do this at 35 centimeters, which if we go ahead and put that into meters, that would be 0.35. And then 0.2 would also be 0.35. This first height would be 0. The second height would be 0.1. And then it should see a yellow line go across it. Beautiful. All good. And then let's go ahead and make our second line, which is going to be at x75, or 75 centimeters. And then it's going to be at 0.75. Nope. 0.75. Again at 0.75. And then the height is going to be 0.1 meters. As you can see, beautiful. So now we have those 2 lines. We want to go ahead and create our chart. So our chart is going to be our velocity profile at both of these points. So for our data series, we're just going to add x35, and our location is going to be x35. Add a new series, it's going to be x75, and then it's going to be at location x75. Then our x-axis is going to be our velocity u, velocity in the x direction, and our y-axis is going to be our y location, y values. We have that. Go ahead and click apply. As you can see, they're pretty sharp. So what we can do is go back to our lines and conduct more samples, do about 1,000 for that one. And then same thing with x75, 1,000. Much better.